One, we are going to talk about numerical analysis and the definition of numerical analysis and the difference between numerical and analytical methods.
The numerical analysis involves the study of all the methods of computing numerical data, and the difference between numerical and analytical methods in 2 points. The numerical methods provide approximation to the problem in question. They don't give the exact solution, but approximate value, while the analytical methods give exact solution with more time consuming. Second point, the numerical method gives solution at certain points. At certain points only, like finite difference and finite elements. These methods are considered numerical since they give results at certain points. We are going to proceed for finding the positive root of a function. First, the definition. What is the root of the function? The root of the function, or they called zeros, they are the points where the function crosses the x-axis. So if we have a graph y equal to x squared minus 4, and we draw it in the x and y coordinates, and while the intersection of the x-axis with the graph will give us the value of f of x equal to 0, supposed to cross plus 2 and minus 2. These 2 points are called zeros. How we get these 2 points? We let f of x y equal to 0, and we make bracketing, so we put here 0, x squared minus 4 between brackets, factoring. It will give us multiplication of x plus 2 multiplied by x minus 2. We equate to 0. So x equal to minus 2, the first solution, or there is another solution that x equal to plus 2. We have 2 solutions, x equal to minus 2 or x equal to plus 2. They are the zeros. Second or last step, that we have to check that our solution is correct. So we plug in with x equal to plus 2 in this equation, y equal to x squared minus 4. We put x plus 2, so 2 to the power of 2 equal to 4 minus 4 give us 0. And for the other solution, x equal to minus 2, we will write minus 2 to the power of 2 minus 4. It will give us 0. Once we have satisfied that f of x equal to 0, we have these 2 zeros, plus 2 and minus 2. Synthetic division. To get the 0 of the function, sometimes we are guessing the value of the x with so-called rational roots test. So the rational roots test is a handy way of obtaining a list of useful first guesses when you are trying to find the zeros of a polynomial. So on our example, y equal to x squared minus 5x plus 6. We have leading coefficient of x squared equal to 1. This one can be analyzed as a multiplication of plus 1 multiplied by plus 1 equal to 1, and minus 1 by minus 1 will give us 1, while the 6, the constant, can be analyzed as either plus 1 multiplied by 6 plus 6, or minus 1 multiplied by minus 6, or plus 2 multiplied in plus 3, or minus 2 multiplied by minus 3. So we have 1 and 6, plus and minus, we put it here. And for the leading coefficient, we have 1 and 1, plus and minus, we put it down in numerator. And comma, plus or minus, we have 2 and 3, either plus or minus, we put plus or minus, and we divide by the leading coefficient 1 and 1. Now we'll proceed to make the synthetic division. We are writing the coefficients only without the x squared or x. We have x squared, the coefficient of leading coefficient is 1, we put it here, and the minus 5, we put it here, and the constant plus 6, we put it here. And first, we let x plus 3 as one solution. which is one of these, 3 over 1, plus or minus. We are getting x plus 3 equal to 0 as first trial. So x will be equal to minus 3, will go there. And we put this minus 3 here on the left side portion. The coefficient of x squared, or the first coefficient, will go down as 1. Then we multiply 1 of minus 3, we put it here. We add minus 5 to minus 3, we get minus 8. Then we multiply minus 3 by minus 8 by minus 3, we get plus 24, we put it here. We add to plus 6, we get plus 30. So these are the steps. We write the coefficients only without x squared or x. The coefficient of x squared carrying down, this one will go down, multiply minus 3 by plus 1, and we put it here, and then we add to minus 5, and all the steps are here. For our first trial, this gives me plus 30, is supposed to give 0 as exact solution, so we'll proceed with another trial. This another trial that we will put x minus 2 equal to 0, so this 2 will go to the other side, lead to x equal to 2, we put here 2. Leading will go down as before to 1, multiplied 1 by 2, we put it here plus 2, we add to minus 5, will come back minus 3, we multiply minus 3 by plus 2, we get minus 6, so at the final step we add 6 to minus 6, we get 0. So our solution x equal to minus 2 is one of the solution, and the other one is this will be
x minus 2 will be multiplied by x minus 3, and they are going to give us 0. So the results show that we have two roots. One root is 2 and the other root will be 3. Thanks a lot and see you in the next lecture. Goodbye.